Hey dosters, what's up and welcome back to another video. Today we're going to be focusing on the first principle. So this is about derivations, the first principle of the derivative. So let's get right into it. So differentiating from the first principle. I hope you all know what differentiating means. I hope you have like a very basic idea of it. If not, we're going to go through that here. So differentiating, so if you're asked to find the derivative of a function from first principle. So there are two ways to do differentiation. So there's the classic, like let's say you have something like x to the power 4x to the power of 4, and they ask you to find dy over dx. This here means derivative. This is derivative. Yes, this is what they mean by derivative. So if they ask you to find dy over dx of this, what you do over here is you apply the derivative rule. That's not what we're going through over here. And then you find the derivative, but that's not what we're trying to do over here. We're trying to find the derivative, but we're trying to find it from the first principle. This is a concept that you have to know for the Maths AHL course. So from the first principle, you will need to use the definition that f prime of x, so this means the derivative. If you have f of x, and then you do the derivative, it becomes f prime of x. That's the derivative function. This is the original function. This apostrophe over here, it means uh, um, derivative, yeah, the first derivative. If you derive this function again, you get double derivative. So second derivative, and then third, and then fourth, and then accordingly you keep on adding apostrophes. So f prime of x is equal to limit as h approaches 0 f of x plus h minus f of x over x plus h minus x. This is the first principle of the derivative of derivatives. And I want to make clear over here that this is a little bit more complicated than it should be. I don't know why the textbook has given it like this, but this is the same thing as limit as h approaches 0 f of x plus h minus f of x over h, because this x over here it's minus and cancels out with this, so these two cancel out and you get this in general. So this is what I want you to look at right now. This is your first principle. This is how you do the derivative of the function. So as limit h approaches 0, h has to become 0, you plug in 0, but it doesn't work because 0 cannot be at the bottom. So what do you have to do? You have to try to rearrange this in such a way that means that you have to rearrange this so that the denominator does not become 0. So you have to remove this h or add something to this h at the bottom. And we'll get into that once we do like a practice question. But right now, I just want you to remember this. This is the first principle of the derivative. So if a question asks you to find the derivative of a function from the first principle, you apply this rule. So what this means is f of x plus h, you plug in x plus h instead of x. So let's say your f of x is equal to x squared plus x. You plug in x plus h. So f of x plus h would just be equal to x plus h to the power of 2 plus x plus h. You're just replacing whatever this is in the x. It's really simple and really easy to understand. You plug in the variable. You do not plug in like any numbers or anything like that. So now let's look at a question. So f of x is equal to x cubed. So they're giving us f of x is equal to x cubed. And now from the first principle, it mentions first principle. If not, please do not use the first principle. I will teach you how to use the normal derivative function in later videos. But if they do not specify use the first principle, please do not use this method. It is really, really extra and just tiring, and normal derivative methods are way easier. But I will teach you that in later videos. Right now, you need to know about the first principle, as they might ask you this. So when you get a question like this, what are you going to do? You're going to go back to your first principle formula. You know that f prime of x is equal to f of x plus h, sorry, minus f of x over h. That is your first principle formula. So now we're going to apply that. So f of x plus h is equal to x plus h to the power of 3. Yes, f of x to the power of 3. f of x is just x cubed. So now we have everything we need. So we plug in x plus h to the power of 3 minus x cubed over h. So now what are we going to do from here? I want you to pause the video and have a go at this. Have a go at trying to solve this. So if it were me, I would just expand this. I would expand this using the Pascal's triangle And from the Pascal's triangle, if you don't know what the Pascal's triangle is, I'll reference that in another video. It's in the sequences video. I will reference that in the description below. Please do go ahead and watch that. If not, just if you don't want to go through that video, just search it up. It is really simple. It just the Pascal's triangle allows you to do expansions very easily. So this is our Pascal's triangle. Yes, you just add up. You just adds to make this. So this is for our cubed, this is squared, and this is just to the power of 1. So this is our squared, but this is our cubed. We want cubed. So from our cubed, we can get x cubed plus 3h of x squared plus 3h squared x plus h cubed minus x cubed over h. So this cancels out, this cancels out. And now what we're left with is 3hx squared plus 3h squared x plus 3h cubed. So now what we see over here that each one of these terms have a h in common, and the only term at the bottom is a h. So what we can do is we can bring this h outside. Let me get a new page. We can bring this h outside, so we can take h 3x squared plus 3h of x plus h squared over h. And this obviously cancels out. And now you get as lim. Sorry, I'm supposed to write lim h approaches 0, but I haven't been. Let me just write that in quick. As limit h approaches 0. As limit h approaches 0 for the function of 3x squared plus 3h of x plus h squared. So what do you end up with? So now you just apply your limit, and the easiest way to apply the limit is just plug in 0 for h. So once you do that, you have no issue over here since there's no fraction. It's not a fraction anymore. And your denominator, you don't even have a denominator. I mean, you do have a denominator, but the denominator is 1 now, and you get no problem with the denominator becoming 0 now. So you plug in h is equal to 0, and you get 0 over here for this term. You get 0, and this becomes 0 too. And you just end up with 3x squared. And that's our answer. That's our derivative of x cubed. The function x cubed derived, so f prime of x is 3x squared. Now, if you don't understand that, I have attached the mark scheme on the next page for you to go through in your own time. I'll be attaching the link of the Canva slides in the description below. Please do go through that whenever you want. And I have attached a practice question for you guys to attempt to with the mark scheme on the next page. So please do go through that too. It's really good practice for you to learn and revise these concepts. So I will be posting the links to multiple videos in the description below. So if you don't understand limits, those will also be in the description below, along with the Canva slides, obviously, and one-on-one tutoring with me for free at any time that is listed in the link. So thank you very much for watching today. Have a good day.